Hello everybody, thank you to Jen's PolarDry webinar. Today it's a pleasure for me to present you a gentle spray drying technology for thermosensitive compound. My name is Audrey Maudhuit, I'm process engineer in Fluid Air. You can find here my email, and so feel free to send me an email if you have any question. So a short word about Fluid Air, who we are. So Fluida, it's a division of spraying system. We are located in Chicago and around the world. The headquarters is in Chicago. And we are specialized in solid dosage equipment like fluidized bed, harsher granulation, size reduction. We do by ourselves the process automatization. And today I have the pleasure to present you the new equipment that we developed. It's an electrostatic spray dryer. So why we decide to develop a new system to dry today? In industrial scale, you have two kinds of drying system, drying process. You have the freeze drying. It's really great. You can work at low temperature and you can preserve the sensitive compound. You have a high yield. But at the end, you have a cake and you have to use a milling system to obtain the good particle size. It's a batch process, so most of the time you need 2 days to obtain one batch, and it's a lot of time and energy consumed just to obtain one batch of powder. On the other hand, you have a conventional spray drying. It's a continuous process. It's really great because you can have a large-scale equipment, for example, for milk in Australia, just an example, and but you have to work at high temperature. Most of the time you need to increase the particle size because the initial particle size that you obtain it's 5-10 micron, so you need to granulate it in, for example, for a fluidized bed with a top spray to increase the particle size. So we try to take the best advantage of each compound, of each technology, sorry. So work at lower temperature than conventional spray dryer, obtain a high yield for sensitive compound, work continuously, and also have a large-scale equipment and do easily the scale-up. After 10 years of research, we concept the PolarDry system. So how it's look like a conventional spray dryer. You use inlet gas. We work at concurrent. That means that we have also the nozzle at the top to spray. We have a cycloning system to dry, so that means that we can increase the time in the chamber and reducing the size of the chamber. So the particularity, we don't have a cyclone at the end. We have a plenary system, so that means that we have filter to separate the drying gas to the powder. And the drying gas that we use, it's nitrogen for two reasons. The first one is to avoid to have an exposure issue due to the fact that we have an electrostatic charge inside, and also it's to continue to preserve your sensitive compound and avoid to have an oxidation during the drying. To be sure that we don't use so much energy and so much utilities, we use a recirculation of the nitrogen. We have for that a dehumidification unit to assure a low quantity of water in entrance, and we have heating systems. What's happened when we use an electrostatic charge? So when we use a conventional spray dryer, you have two phases. On the first phase, when you start to dry, to evaporate oil easily, you dry, you evaporate the water at the surface. But after that, you have the creation of the crunchy shell, and it's the same when you have bread on your oven. You have to evaporate your water, stay in the middle, and it's really hard. You create a lot of capillarity, porous capillarity to evaporate your water, and you need to increase your temperature to evaporate this, that we can say link water in the middle. So in case of electrostatic charge, the fact to apply an electrostatic charge in the liquid. We help the water to move really faster to the surface. So that means that we don't have water in the middle. We have only the active in the middle, the active or the carrier. And we create a thin layer of water around the particles, really easy to evaporate. So we don't need to increase the temperature. And moreover, the fact that we create this thin layer of water around the particles, we can protect the active during the drying. It's the same thing that when you go to the sea and it's 40 degrees C, sorry, I'm French, outside, and when you go to the beach, it's really cold. It's to choose a thin layer created on your sink. So it's really great, and the most important things for us when we work with PolarDry is to control the outlet temperature. Moreover, if we have an emulsion, for example, and we want to encapsulate oil or active compound, but we can say today oil. So this is oil that we have in yellow, and we have a carrier, for example, modified starch. When we dry with conventional spray dryer that we obtain an homogeneous repartition between your carrier and your oil. That means that you can have oil at the surface like this, and that means that we don't have a really good protection of your oil. Moreover, if you use essential oil, you will have an evaporation of your essential oil and it will smell a lot. In the case of electrostatic spray dryer, we work on the polarity of the compound. That means that we play on the polarity of the compound to stratify every composition. So that I say most of the time we use water. It's a more polar compound that we know. So water we will move fast at the surface, and after we choose a carrier a little bit more polar than the active. So that means the active will stay in the middle, don't move, and the carrier will coating, we can say that, will coat the active compound to obtain a really good microencapsulation and without oil at the surface. So that means that we can increase the shelf life and the quality of your encapsulation. We do that with low temperature and we obtain exactly the same moisture content that we have with a conventional spray dryer. So, okay, it's really great to know that, how it's worked, but for which application? So, to be honest, we start 2 years ago and we discover every week a new application. So, feel free if you have some idea to call us and to say, yes, I want to try this technology with a new application that we think really great in the future. And just to give you some ideas that we did now, we have good result when we encapsulate active pharmaceutical ingredient because that we change the shape and the surface of the particles. That means that we can also change the behavior, for example, the flowability, the compressibility, and we see with tablets that we don't need to use. We can go directly to the direct compression and we don't need to use a fluidized bed, high shear granulation and milling to obtain a good powder to compress it. We also have many applications for virus and also with microorganisms, with probiotics. I will show you an example after that. We also encapsulate fish oil, omega-3 or antioxidant compound. We have some case of study on essential oil, for example, to mask test in feed application, for example, and we have also some application on dye pigment with we keep the color of this kind of compound. And as that I say we also have a good flowability of the powder that we obtain a good dissolution. So sometimes functional food also use PolarDry. So I will present you 3 cases of study today. The first one is for macroalgae. We work with a university in France, and they cultivate 2 microalgae. They concentrate it. It's also you have to know that we need a concentration of more than 8% to dry it, of mass content. And so we decide to compare a conventional spray drying, in this case it's a bouquet, with the PolarDry, so electrostatic spray dryer. For this study we chose to use the same inlet temperature at 90 degrees C. So the first result that we obtain, we compare the water activity of the powder that we obtain for these 2 kinds of microalgae, and we saw that in case with PolarDry, we have a water activity below 0.3 to compare with the conventional spray dryer that we are really higher than 0.4. In this case, at 0.4 of water activity, we know that the shelf life will not good. You don't have a stability during the storage. And moreover, we also compare the energy that we need to dry. And in this case of with the conventional spray dryer, we use 30% more energy to dry it due to the flow rate of the drying gas, and also due to the productivity that we have. We also compare the pigment gain that we can obtain when we dry with the electrostatic spray dryer and conventional spray dryer to measure, to calculate the pigment gain. We do electrostatic spray dryer pigment concentration minus the concentration that we obtain with conventional spray dryer divided by the concentration that we obtain with conventional spray dryer. So we obtain this result. In case of chlorophyll A and carotenoids, we can increase by 30% more the concentration of these 2 compounds. And in case of chlorophyll C, we can see that we can go up to 130% of this pigment inside the powder. You can also show the quality of the powder that we have with the conventional spray dryer, that we can see it's a little bit burn and oxidative. And in case of the electrostatic spray dryer, you obtain a really beautiful color. And to be honest, the university was really surprised by the color that we can obtain with the electrostatic spray dryer. Of course, we use nitrogen, so like that we can also avoid to have oxidation of the product. The last slide on the macroalgae trials, it's SEM pictures. The fact that we can work with the charge, we can also we can modify the charge. We can have different frequencies of charge that we applied, and like that we can also agglomerate. That means that we apply a low charge and the particles stay a little bit sticky, and after we apply a high charge, and like that the particles stick together and can fix this agglomeration that we create. It's that we want also to show here, in both cases we use a bifluid nozzle at the same atomizing pressure, that we can see with conventional spray dryer we have a particle around 50 micron, and here, and when we work with the electrostatic spray dryer, we increase the size by 2-3, we have more around 50 micron. It's the same case with the N-Oceanica. You can see that we can also increase the size of the particle due to the fact that we can granulate the particle. Moreover, something really interesting, it's the shape that we obtain. We obtain a morphology totally different that we can have with a conventional spray drying. That means that we develop a new functionality. We continue to work with university to understand what is new functionality could help for aquaculture, for example, or for food, for increase the wettability, the dissolution. So we continue, but it's just to say you that we obtain something new. I will show you a video of the wettability of the powder that we obtain, so that we can see we have something really wettable with a good wettability, and also you can see the beautiful color that we obtain. I want also to show you another case of study that we did in US. We dry probiotics, and the collaboration cultivated, and we do also formulation. To be honest, it was the first trials with probiotics, and we use trehalose and maltodextrin like carrier. In this case, we wanted to compare the freeze drying and the conventional and the electrostatic spray dryer. We really be careful to work with the outlet temperature at 37 degrees C. So the result that we obtain, so we wanted to compare firstly the viability after the drying between the freeze drying and the electrostatic spray dryer that you can see here, and we obtained exactly the same value. After we checked the stability in 4 weeks in incubator at 37 degrees C and at room temperature for 6 months, and that you can see the results are really close, with a high value for PolarDry at the end after 4 weeks, and but if you see, we obtain really close the same curve. It was exactly the same and more close in the case of the storage at room temperature. That you can see, we obtain the same shapes. That means that we have something better or comparable to the freeze drying, but with using less energy and working with like batch process. We did also, so this trials was done with Lactobacillus plantarium. So did this result with this experiment with Lactobacillus caesae, and you can see also that we obtain the same shape of the stability over the time. So just to give you an idea, so for the production cost in this case of PolarDry, it's 4 times less than for the freeze dryer. If you take in account the invest, the utility cost, and also the operating cost. So to finish the case of study, I wanted also to show you one case of study on essential oil. We use mint oil, and we use ultra-thorax, which we make the choice to use a microfluidizer. It's something close to the homogenizer at high pressure. And in this case, we compare with conventional spray dryer, a bulky one, electrostatic spray dryer, and the freeze dryer. In the same case, then for microalgae, we decide to use exactly the same inlet temperature. So yet this trial, but the first results that we have with the SEM picture show in this case that in case of conventional spray dryer, that you can see we have black spots a lot of on the surface of the particles, and also we have something really porous that it's not the case in electrostatic spray dryer. We saw a little bit slow pot here, but nothing to compare with the conventional spray drying. And in case of the freeze drying, the fact to obtain a cake, and in this cake you cut, you mill this cake, you open your pores, and you don't have a really good encapsulation of essential oil. We continue this study, and we hope to give you soon more data. I say you that we also change the behavior of the particles that you obtain. I also explained that the fact that we can work on the charge, apply a low and high charge, so we can increase the particle size. So that you can see here, it's a study that we did with vitamin C, and that you can see we increase the particle size up like this, so that we obtain with a conventional spray dryer, and with the electrostatic spray dryer we more have a particle size around 100 micron, to compare something like 10 to 50 micron with a conventional spray dryer. I will show you also a video to show you the hydration. So it's that we obtain when it's an oil encapsulation with modified starch. So we compare the hydration with a conventional spray dryer that you can see here, and also with the PolarDry that you can see we obtain a perfect hydration of the powder, also due to the shape that we have and also the particle size that we have also. The last one, it's a powder, it's oil encapsulated in modified starch. Here it's the conventional spray dryer, and that you can see we don't have flowability at all. We have a powder really hygroscopic, and it's not the case with the conventional with the electrostatic spray dryer with PolarDry. We obtain really good flowability of the powder, and this sample has two years now, and that you can see we continue to obtain a good flowability after 2 years. So just to conclude, when we use an electrostatic spray dryer, you have an electrostatic effect. This electrostatic effect it's great because like that you create a stratification of your compound, and you help the water to move at the surface, so you don't need to apply high energy and high temperature. You work at low temperature. Moreover, the fact to stratify your compound, you increase your encapsulation efficiency, and also you can play on the electrostatic charge to granulate your powder. So you can do all in one system. We have a continuous process, and we really be careful to have a recirculation of nitrogen, to don't use so much utilities, and it's perfect. We have a perfect scalability between the model 0.1 that you can show here. So it's a tabletop that you can put on food, and so we can go to the large scale to a model 200. It's 2 tower of 15, and when you say 0.1, 1, 4, 32, and 50, it's a maximum evaporation of kilogram of evaporation of water per hour. So as we can see, we have a large scale, and we have, so in each laboratory we have the model 1 that you can test, and the model 0.1, and I'm happy also to show the model 32 in Chicago if you want to do some trials on this big one. Thank you so much for your attention. It was really a pleasure for me to do this presentation. So you can see the website link, sorry, and also my email if you need more information. Thank you so much. See you soon.